Okay, hey guys, this is a video lecture on graphing rational functions, section 1, vertical asymptotes and domains, the first section in this chapter. So obviously we're going to discuss vertical asymptotes and domain, two things that we've talked about before, um, and we've seen them in the past couple of chapters. Domain you haven't really spent a lot of time on yet this year. You did a little bit of it when we were doing Algebra 2. But vertical asymptotes, that should be fresh because that should be something that, that's one of the more recent things that we did in the previous chapter. So you'll see some crossover. First, you're going to get a whole procedure. Now, this chapter is called Graphing Rational Functions, but we have a lot of things to do before we get to actually graphing them. So we're probably not going to graph until, 3 or 4 lessons from now. We got to learn about specific things, about vertical asymptotes, horizontal asymptotes, what we call holes, x-intercepts, y-intercepts. So there's a lot that needs to be done, and there's a whole list of steps we're going to develop on the procedure for graphing a rational expression. The first 5 of those steps we're going to cover in this video. We're going to go through all these today, and they're written out here in detail. And now, obviously, I already have this typed out for you here, and you need to copy this down in your notes. So, if at any point the video is going too fast for you because you're frantically writing and you're not listening, what you can do is simply pause the video, copy down what you see on the screen, copy down the notes, copy down factor, numerator, denominator, yada, yada, yada. Copy it all down, and then unpause it and move on. So you have that ability to control the video's time at home. So make sure you use that wisely. And of course, you could always go back and rewatch the video if you missed something, but definitely pause it and try to keep up with what you're hearing in the video, not just what you see. So let me talk about these one time. First of all, a rational expression we've been dealing with. We just finished doing rational expression inequalities. So we're familiar with rational expressions. It's basically an algebraic fraction. There's some something with x on the top and something with x on the bottom. They could be trinomials or binomials or monomials or crazy polynomials. We've gone pretty in depth with that already. So you're familiar with what a rational expression is. The first step to graphing them is to factor the numerator and the denominator. And there's nothing fancy about that. We usually don't get too crazy with the factoring here. It's going to be a basic GCF, a trinomial, a difference of two squares, maybe a combination of the two, but the factoring is not going to get to a very crazy level. So it's going to be some basic factoring. Once you factor, you're going to write it in lowest terms. And basically what that means is if the top and the bottom have a common factor, you're going to cross it out. You're going to reduce it. Step number 3 is set the denominator not equal to 0 and then solve that. And that's what's going to get you the vertical asymptotes. And we've already done that. We saw that when we did the rational expression inequalities is basically, find the zeros of the bottom and, the denominator. And because they're on the bottom, we can't have undefined expressions. That's why it's not equal to as opposed to equal to. But I'll explain that in more detail when we get to the examples. And then the last step here, step 5, which is really, I think, the new piece for us, is writing the domain. Now, first of all, I like this notation, capital D subscript X. That's the symbol I'm going to be using this chapter to represent domain. And it's a good symbol because D stands, has the letter D for domain, but it also, the little X reminds us that domain is X. Range is Y, domain is X. And we're not going to do much with range, but we will be seeing a lot of domain here, so just keep in mind that domain is X, and that's one way to do it. And we're going to write the domain with interval notation, and that's also something we spent a lot of time on the past couple of days. So let's get started with some examples, and we'll go through these step by step. So here's our first example. Again, what you could do is you could pause the video, write it down real quick, and then unpause the video, and then I'll go over it with you. I'm not going to just stop talking and let you write for a little bit. So you're going to have to control that on your own. So I would suggest pausing and writing and then unpause. But so anyways, at this point, I'm assuming you've unpaused the video and you already have this problem written down. So step 1 was to factor the numerator and the denominator. This is a very basic example where there is no factoring involved. You can't reduce these x squared over x because this x minus 5 is a a binomial, a polynomial, so we can only cross out x minus 5 if we had, say, another x minus 5, which we don't. So there's nothing that can be done. It's written in lowest terms. There's no reducing. There's no factoring. So steps 1 and 2 are done. Step 3, set the denominator not equal to 0 and solve. And so you solve it just like it's an equation with an equal sign. And this, I think a lot of you can just do in your head. Basically, we're saying, what's going to make this 0? What's going to make it undefined? And the clear choice here is positive 5. But you can see, if we were to solve it like an equation, we could add 5 on both sides, and you would get x is not equal to 5. This is your vertical asymptote, and we're just going to write VA. So that's steps 1 through 4. Now, steps 1 and 2 didn't really matter here because it was not factorable and written in lowest terms, but that's basic factoring that you guys can do. Step 3 and 4 is find out what's going to make the bottom undefined. Find out what's going to make the bottom 0 and write it as x cannot equal that. Because x cannot equal 5. If x was 5, this would be 0 and the whole thing would be undefined. So that is a vertical asymptote. And if you were to see this on a graph, positive 5 would be about here. You'd have this, the calculator wouldn't show the dotted line, but there'd be some line where your graph wouldn't get, it wouldn't be continuous at that point. There's a gap of the line. So, and, we'll get much more into the graphing later on in the chapter. But anyway, so that's the vertical asymptote. Next, the last thing we need to do is just write the domain. The domain, we're going to use the notation d of x. So here's domain. And using interval notation. Now, the vertical asymptote is how you kind of figure it out. These are extremely related because your domain is everything x can be. And what we now know is that x can be everything, all values of x, except it cannot be 5. So what that means is x goes from negative infinity to 5, and it's a parenthesis for 5 because it's an asymptote, can't equal that, or 5 to infinity. And so this is our way of writing an interval notation that x can be everything except the number 5. All right, let's look at another example. I'll go to a full screen now that we hopefully have a good sense of the rules here. Step 1 is to write it in factored or reduced form. So nothing you can do on the numerator, but we could factor the bottom, the denominator, x plus 2 and x minus 2. And there's nothing to cross out, nothing to reduce, so we're done there. Set the bottom, not equal to 0, and solve. We end up that x cannot equal negative 2, and x cannot equal positive 2. These are going to be vertical asymptotes. That's it. Your domain, now that we know x can't be those things, always starts from negative infinity, and it's going to go to negative 2, or it's going to go between negative 2 and, I just want to rewrite that so that's clear. Negative 2. Nope. Sorry about that. Or negative 2 to 2, because x can be all the numbers between negative 2 and 2. It just can't be those two numbers. Or it could be all the numbers between 2 and infinity. And the nice thing about this is because we're dealing with asymptotes as kind of our key numbers here, it's always going to be parentheses. You're not going to have any brackets to deal with because it's parentheses for the infinity and it's parentheses for the asymptotes. So that's it. So let's move on. All right, here's another one. Now again, you need to maybe pause the video, write the problem down, and then unpause because I'm going to jump right into solving it. So the numerator can be factored to x plus 3 and x minus 3. And this is a classic difference of two squares, classic dots, over the denominator is a trinomial, factors to x plus 7 and x minus 3. They have a common factor this time, and we can cross that out. So the x plus 7 is the only term that's left over in the bottom that gets set equal or not equal to 0, which gives us a single vertical asymptote of x cannot equal -7. Now your domain, let me move this over a little bit. Your domain still uses this term here. See, there's two numbers down here that if x is -7, obviously this would be 0, and that's what we found here, and that's a vertical asymptote. Now we crossed out the x minus 3 here, but that's still a number that x cannot equal +3. X cannot equal +3 because that would make your original expression undefined because it's a factor of the denominator. But it's not a vertical asymptote because they get crossed out. So it doesn't go in the vertical asymptote category, but it is used in the denominator category. And that's one of the challenging things about this. When you have factors that cross out, it's not an asymptote, but it is part of the restriction for your domain. The crossing out aspect of it actually is something called a hole, which is going to be discussed in the next lecture. So your domain would go from -infinity to -7, or it would go from -7 to 3. And what we're saying is x can be all the numbers from -infinity to -7. It could be all the numbers between -7 and 3. And it could be all the numbers from 3 to infinity. It just can't be 3. It can't be -7. And -7 is an asymptote here. 3 is what we call a hole. But we'll discuss that more in a later video. All right, so maybe let's just look at one more video, one more example here, and we see that again. Pause the problem, pause the video, write it down. Okay, good. Welcome back. So I'm sure there's plenty of you that are not actually pausing that. You're just frantically trying to write it down and keep up. Just really pause it, take your time. You're gonna get a lot more out of it if you're listening to what I'm saying, because I know it is difficult to write and listen at the same time, with deep focus anyways. So the numerator here cannot be factored. So that's gonna stay 5x. The denominator has a greatest common factor of x squared. You take that out, you're left with an x minus 3. And so nothing can be reduced, but that is the expression in reduced factored form. Set each of your factors here not equal to 0. And taking out an x squared is just like taking out an x. You're just going to end up with x does not equal 0. I mean, doing the square root of 0 is just 0. You don't need to worry about plus or minus 0 because 0 isn't really a number like that. And the x minus 3 cannot equal 0 gives us x cannot equal 3. And these are the vertical asymptotes. And lastly, we just need a domain. So you know your domain is every number except 0 and 3. So that means from -infinity to 0, all the numbers between -infinity to 0 are in the domain. And all the numbers between 0 and 3 are in the domain. And all the numbers between 3 and positive infinity are in the domain. And that's it, guys. Just going, factoring things. I mean, you'll see there's more examples of more, this one down here maybe requires some AC factoring, or use completing the square, or type it into your calculator and trace out the roots. I'm not going to give you problems here where your roots are, well, maybe not that many problems anyways, where your roots are irrational or stuff like that, so they should be fairly factorable terms for the most part, the majority of the problems anyways. So, you could try factoring on your own. If you can't factor, use your calculator. Try to trace out the roots, or you could do completing the square, whatever you need to do. I mean, this is not a basic trinomial. AC factoring should work here, but you have other methods you could do. Once you factor it, see if anything crosses out. If they do, what's left over, set it not equal to 0, get your vertical asymptotes, and then use those numbers to identify a restriction on the domain. And that's it. That's finding vertical asymptotes and stating the domain of a rational expression. In the next video, we're going to talk about what happened over here with these terms crossing out, and I mentioned that this creates something called a hole, but we're going to discuss that in the next video. See ya.